My viewers, today I'm going to explain linear differential equation. Now, given a linear equation of this form, how do we solve this type of linear ordinary differential equation? All we need to do is to determine the integrating factor. And after determining the integrating factor, we multiply all the sides by the integrating factor as seen from this equation. So when we have a differential equation of this form, this is the procedure on how to solve them. All we need to do is to write our y, thus the exponential of the exponential, and we integrate the value of what? P of x to be equal to the integral of q of x times the integrating factor plus a constant. Now, I believe with the example, we are going to understand how to solve this problem. Now, let's look at example 1. We are given the y ds plus y over x to be equal to 3x. So the first thing we are going to do is to determine our p of x and our q of x. Now, from this linear equation, what's our p of x? Our p of x equals 1 all over x. And our q of x equals 3x. Now, from this, we can easily apply this rule. And what is the rule? We have y dot exponential integral of p of x to be equal to integral q dot integrating factor plus c. Now, let's determine our integrating factor. Our integrating factor, I denote that with if, integrating factor, will be exponential of integral of p of x. And what's our p of x? Our p of x is 1 over x. So we have integral of 1 all over x dx, which at the end of the day will give us e. The integral of 1 over x is ln x, which will give us x at the end of the day. So our integrating factor is what? Is x. Now let's use that procedure. Then we have our y dot the exponential of integral of p of x to be equal to integral q dot integrating factor plus c. Why? Since we got our integrating factor, e raised to power integral of p of x to be x, so the whole of this will be x, which is equal to the integral. What's our q? Our q is 3x dot integrating factor, which is what? X, all plus c. Having said that, we have our yx to be equal to integral of 3x squared plus c. So yx will be equal to, now integrate this, we are going to have 3x raised to power 3 all over 3 all plus c. So yx will be equal to 3, you cancel out 3, we are left with x cubed plus c. But we can let's make our y the subject of the formula. So we have y, when we divide all the sides by x. So we have y to be equal to x squared plus c all over x. So that's our final answer. So y equals x squared plus c all over x, where c is a constant. Thank you. Yeah, let's solve the second example. Our second example here, we have the y ds plus y sec s equals tan x. Now, let us determine our p of x. Our p of x will be equal to sec x, while our q of x will be equal to tan x. Now, having said that, the next thing is to determine our integrating factor. And our integrating factor, if, will be equal to what? Exponential of our integral of p of x ds. Now, what's our integrating factor? Our P of x is what? Sec s. So E will be integral of sec s ds. Now, if we integrate sec s, we are going to have E ln sec x plus tan x. So at the end of the day, exponential and ln will be cancelled out and we'll be left with sec x plus tan x. So that's our integrating factor. So our integrating factor is sec x plus tan x. Now, if we follow the procedure, our y dot integrating factor will now be equal to the integral of q dot integrating factor all plus c. So y dot, what's our integrating factor? Sec s plus tan x. So that will give us sec s plus tan x to be equal to the integral of q. Our q of x is tan x. So we have tan x times our integrating factor, which is sec s tan s plus tan x all plus c. Now, let's left this aside and let us solve this problem on the right hand side. If we do that, we are going to have sec s tan x plus tan square x integral all plus c. Now, we can separate this integration by writing integral of sec x plus sec s tan s plus integral of tan square x all plus c. Now, if we integrate sec s tan x, we are going to have our sec x all plus the integral of tan square x. Remember, in our trigonometry, we have our sec square x, sine square x plus cos square x to be equal to 1. Right? So if we divide all the sides by sine square s all over sine square x, we have 1 plus cos square x to be equal to cosec square x. And if we divide by cos, you have tan square x plus 1 to be equal to sec square x. So tan square s is equal to sec square x minus 1. So instead of writing tan square x here, we can write sec square x minus 1. So our integral here will give us what? Sec square x minus 1 all the x plus c. So we can have our sec x plus the integral of sec square x dx minus the integral of 1 dx. So this will give us sec square x plus. Now let us integrate our sec square s. If we integrate sec square s, we are going to have sec square s. We are going to have tan what? Tan x. So this will give us tan x minus, if we integrate this, we have what? We have our x all plus c. So integrating sec square s will give us tan x. As we all know that the opposite of differentiation is integration. If you differentiate If you differentiate tan x, you have your dy to be equal to what? Sec square x. So if you integrate sec square x, you have tan x. So that's where we obtain that from. So having said that, we have all this. Don't forget that the whole of this gave us this. So we can bring this back. So we have our y sec x plus tan x left here. Then we want to make our y the subject of the formula. So y, we divide through by sec x plus tan x. So y will now be equal to, the whole of this is sec x plus tan x. So this, we can combine them together. We can have our plus c minus x. So let's divide all the side by sec x plus tan x. So we have sec x plus tan x. Let me put it like this. Sec x plus tan x divided by sec x plus tan x. Now, what I'm trying to do here is to separate them. So if I separate this, I can have sec x plus tan x. And this can be written in form of x plus c minus x. So I try to separate both expressions. Now, having said that, we are left with this. Now, from the question on the board, we can easily write this to be equal to y to be equal to, when this divide this, we have 1. 1 plus c minus x all over sec x plus tan x. So this is our final answer. Thank you very much. Linear differential equation. So this is a question, and the first thing to determine is to determine our p of x. Our p of x equals cos x, and our q of x equals half sine 2s. Now, after you determine your p of x and your q of x, the next thing is to determine our integrating factor. And our integrating factor, as stated earlier, equals exponential integral p of s ds. Now, what's our p of s? Our p of s is cos s ds. So that will give us the exponential of raised to power s. So our integrating factor is exponential raised to power sine s. Now, if you can determine your integrating factor, the next thing is to write the solution in this form: y dot the integrating factor to be equal to the integral of q of x dot the integrating factor all plus c. Then let's make our substitution. This is our y. What's our integrating factor? Our integrating factor is exponential raised to power sine s to be equal to the integral of, what's our q of x? We have half sine 2s multiplied by our integrating factor, which is what? Exponential raised to power sine s all plus c. Now, let us solve this. On solving this, let's do this separate. Let me put this as equation 1. So let's solve this equation 1. We have integral of half sine 2s dot exponential raised to power what? Sine s. Now, this is a constant, so we can bring the constant out of the integral sign. So we have sine 2s dot e sine s. Don't forget all plus c. Now, let u be equal to sine s. If our u is sine s, that means our du will be cos s. So let us rewrite the integral. So we now have our half to be integral, so instead of writing our sine 2s, we can write it in form of 2u. Because our u is sine s, sine 2u will be 2u. Dot, which is multiplied by exponential u, all du. Now, 2 will cancel out 2. So we are left with u dot eu, all du. So let us use our integration by parts, which states that uv minus integral of v du. So our w equals u, an assumption. Then we have our dw to be equal to du. Our dv will be equal to eu, then our v will be eu. So from the rule of integration by parts, our uv minus integral of v du. So what's our u? We still have our u, our dv is ev, minus the integral of v. Eu does eu, du rather. Eu does du. Our v is eu, and our du is still du. So at the end of the day, we have, at the end of the day, let me continue from the upper part. At the end of the day, our eu minus the integral of eu is eu. So we have minus what? Eu. But let us recall. We recall that we said our u to be equal to sine, our u to be equal to sine s. So which implies that this eu minus au will be sine s e sine s to minus e sine s. So we have this. So we can make the substitution of this in equation 1. So the whole of this, the whole of the integral here can be written as sine s e sine s minus e exponential raised to power sine s. So the whole of this will now be e y rather exponential raised to power sine s to be equal to sine s exponential raised to power sine s minus exponential raised to power sine s. So we want to make our y the subject of the formula. So we divide by the coefficient of y. And the coefficient of y is exponential raised to power sine s. So let's divide both sides by this. Exponential raised to power sine s divided by exponential raised to power sine s divided by exponential raised to power sine s. At the end of the day, this will cancel out. We are left with y, and y will be equal to, this will cancel out, this will be left with sine s, and sine s minus, this will cancel out this, we have 1, we have this 1, all plus c. So that is our final answer. Our final answer is equal to y to be equal to, our final answer rather is y equals sine s minus 1 plus c, which is a constant. Yeah, thank you. In the next example, I'm going to solve example on Bernoulli equation. How to convert Bernoulli equation to a linear equation and solve the resulting linear differential equation. Now, I need to add one or two explanation to this. Now, why dividing by exponential raised to power sine s? You should remember that we are dealing with indefinite integral and the plus c is here. So we need to add c, a constant. So this c also will be divided by the exponential raised to power sine s. So at the end of the day, we are going to have exponential raised to power sine s will cancel out this. We are left with y. So our y here, our y our y will be equal to, so exponential sine raised to power sine s, we cancel out this, we are left with sine s. Exponential raised to power sine s, we cancel this, we are left with minus 1. So this is minus 1. And for this, the constant will also be divided by exponential raised to power sine s. So that is where I need to explain to my viewers. So we are left here with plus constant all over exponential raised to power sine s. This is our final answer. But it can also be rewritten in this form: y equals sine s minus 1 plus constant raised to minus sine s. So this is our final answer. Yeah. Thank you.